Hey, it's Simon from electricaltradeacademy.com.
Following on from my tutorial explaining the relationship between voltage and current, in this one I'm going to demonstrate how those core properties are inherent in Ohm's law, one of the two most fundamental formulas, the other being the power triangle, which I've had to cover in a separate short tutorial, that we use almost daily in our electrical work. So let's get started. Now, Ohm's law expresses the relationship between voltage, current and resistance, but note that resistance is known as impedance in AC electrical circuits because it takes account of other factors induced by the AC waveform, but we'll look at that matter in another tutorial. Now, this is how it works. In this practical example, let's say we want to manually calculate the three different values, voltage, current and impedance, of an AC circuit. The tester shows me that the circuit has an impedance of 0.17 ohms and 1390 amps of prospective earth-fault current. So using Ohm's law, let's firstly work out the line voltage. We put our imaginary hand over the value we want to obtain, in this case V for volts. This gives us a formula of I times R. Plug in the values we have, and that's 1390 multiplied by 0.17, which equals 236 volts. Or 236.3 to be precise. Awesome. So now that we know the three values of the triangle, let's play further. Let's calculate the prospective earth-fault current, or just think of it as current. The formula is now V over R, which is 236 divided by 0.17, which equals 1388 amps. But it's actually 1390 if I'd included the 0.3 of 236.3 volts. And lastly, let's calculate the impedance. The formula is now V over I, which is 236 divided by 1390, which equals 0.1697. Again, you can round that up to 0.17. So with those examples, the circular relationship should now be easy to understand. So just as an aside, you may be wondering why we denote current as I instead of A for amps. Well, that's because it was the French physicist Ampère who originally documented current as the intensity of the electric flow. So using a term as long as the French baguette, it comes from the first letter of the phrase intensité du courant électrique. And apologies for my poor French pronunciation.
Now, if you found that useful and informative, give me a thumbs up and consider subscribing where you can opt in for new video alerts. See you on the next one.